All right, we're in the second half of the intro to logs 5.6, and there are two methods of solving equations when the x is up in the exponent that we've already explored. One is guessing and checking, and the other is graphing. So our old ways of doing this would be to do 10 squared. No, 10 cubed, too high. 10 to the 2.5, I don't know. Then you would keep guessing and guessing and guessing until it showed 300, right, on the screen. The other way would be to go to y1 and graph 10 to the x, and that would make this. And then go to y2 and put in 300, and that would graph this, and finding out where they intersect, right? Now, if you had to count the keystrokes there, whoa, there'd be a lot, because you'd have to go to the window and adjust the window and everything, and it would be a bit much. So it's a tried and true method. It's always there for you if you forget anything, if you forget how to do everything I'm about to do right now. Now, the other two methods of solving an equation like this for the exponent, they both use logarithms. One incorporates rewriting this as a log and then just solving on the calculator. The other involves logging both sides and then using another property of logs to get to the answer. So method one will be log. What's the base in this problem? 10, do I have to write it? Of 300, the exponent is the answer. So all you have to do to get x is type in log 300. The answer was 2.477, and my 2.5 guess was a little too high. 2.477, and that's rounded to the nearest thousand. All right? So that's a good approximate answer for what that missing exponent was. That's probably quicker than graphing, definitely a little less stressful than guessing and checking. I don't know if it's really stressful, but time-consuming. All right, in B, you could probably guess pretty easily what the answer here is, right? But I'm going to go ahead and use this method in red for this problem. And here we go. Instead of rewriting as a log, the other way to do these is to take the log of both sides. And that's more natural, I think, for students to do. They want to do something to both sides of the equation to solve for the variable. We've been doing that for a long time, since early middle school. Do something to both sides, add to both sides, subtract to both sides, from both sides, and so on. So logging both sides is a valid method. Now here's the reason that works. There's a property that says if you have the log, this is one of the rules I had on the board last week. What's that? Yep, if there's an exponent in the log. See how that has an x as an exponent inside the log? Here's what you can do with that exponent. You can bring it around front and multiply. It's related to the rule from earlier this chapter when we had an exponent to an exponent. Remember, this to the that? We were going to make a rap for it or something like that. This to the that. What did you do with those two exponents? Like x to the a to the b. What did you do with a and b? Multiplied them. It's related to that rule. We have the log to an exponent. When you log something, it is an exponent. You're finding the exponent. So what would you do with an exponent to an exponent? Multiply them. Okay? That's where the rule comes from. There's a proof that we can do later this week, which I will offer if you know how to do the proof to earn some bonus points. Okay? Okay, good. So, using that rule, where can this little x go? In front of the log 5. And now that we have x times log 5, how will you get rid of the log 5? Divide both sides. These cancel. X equals calculate this in your calculator. The log of 25 divided by the log of 5. There's your change of base property. Log of 25 divided by log 5 is 2, which was kind of obvious at the beginning, but I wanted to do an easy problem to start you off with that process. All right? So C, you can choose the blue or the red method. It's up to you. You can either rewrite it as a log or log both sides, get the answer. I'll pause the video, and we'll see how you did. And we're back. The answer is -2. I used the process where we just rewrite it as a log. The base is 10, so I didn't even write it. This little base of 10 normally goes there, but since it's a 10, you don't have to write it. The x that you're looking for is the answer. This is done easily on the calculator. Just type in log 0.01, and it should say -2. These are two problems that I'd like you to put on the back of your notes guide for this section. And what we have here, we're solving for the exponent, and it's more of a multi-step process. So in example A, the black one, there's one step for you to do prior to incorporating logs. You want to get rid of that 4 by dividing prior to incorporating this newly found method of using logs. In the red one, example B, there's one thing to do again. Divide out that 800 before you incorporate logs. So it's just another step in the process, and you need to know when to use it. When in the order of operations do you use logs? Example B will help us with that. It should be step 2. Step 1, divide the 800. Step 2, use logs, and then proceed with the problem. Okay? In A, you should have divided both sides by 4 by now. Missing a number. 2. Okay, so we have 10 to the x equals that. Here you could go down one of 2 paths. Rewrite as a log. When I don't write the number, it means the base is 10. If I do write the 10, it's no problem. Or you can log both sides. You might want to be comfortable with both of these methods, because I think some people use this sometimes and use that sometimes. Either way, you'll get the same answer. When you type this into the calculator, what's x? It should be 3 point something. 3.05? 065, okay. So that's x. That's if you use the rewriting process, where you rewrite it, type it in. Method on the right. The x comes down. Now, normally, in the next step, you would divide both sides by this. It's not necessary here, because what is the log of 10? It's 1, right? Remember, when you log 10, you're saying 10 to the what is 10? 1. So on the left, we really have x times 1, which the 1 is irrelevant. So the answer is just going to be x equals the log of 1162.5, which we already know is 3.065. All right, I'm going to pause the video. You guys are going to think about a math problem that would be modeled by this red equation. Think money, banks, time. Come up with a problem that goes with this problem, a word problem. All right, so what's a problem that could be modeled by this red equation involving money? How much money would we invest? Okay, 800 is invested in the bank. What are we trying to get it to turn into? 1,000 is our goal. How often is the money getting compounded? 3%. The 3% is the annual interest rate, called the APR, annual percentage rate. It's compounded monthly. I know that it's monthly because of the 12. The answer that we get is going to be what? The number of months. If you divide by 12, you'll get the number of years for it to take to reach that goal. Okay? So what we're going to do is the order of operations in reverse. We're going to divide out the 800 first. And what do you get? The x equals 1.25. Okay, good. Then what? Do the stuff in the parentheses. I think that came to 1.0025. Agree? Then you have two different paths you can take. It's all on your comfort level. If you're more comfortable rewriting that as a log, go for it. If you like logging both sides, fine. Let's pick one for this problem. Log both sides. By the way, I failed to mention this earlier. When you log both sides, or when you use the change of base property, what base are you automatically putting everything in? It's not written, so what's the base? 10. You're automatically putting everything into base 10 so that it can be easily done on your calculator. Okay, you could log both sides in a different base, but that would be silly. You want to put it in the base that your calculator uses. Okay, I'm going to undo the green there because we don't need to write the 10. Next, the x comes down. Why don't we just kill two birds with one stone here? We're going to write the x over there on the left, and after doing that, what would I divide by? I think we're good enough to do this, both of these at once, right? So bring the x down and then divide by what it's attached to. That's how we're going to arrive at the answer. Give it to me to the nearest month. You got 89? Rena, I think you got 89 also. 89.3. We'll just go 89 months, which would be roughly 7 years, a little more, okay? It would be sometime during the 90th month. Your money would reach $1,000. All right, that concludes the examples that I wanted to do for logs. Your homework, you can start now if you like, is to complete the white sheet that I gave you. And tomorrow in class, we'll be working on the green sheet, and we'll be learning about the graph of log. Yay! Another parent function for us to be familiar with.